This is lecture 7 for week 12 of CS 1030. And in this lecture segment, we're going to keep going with the theme that we started in the previous one, which is conditional control flow. And instead of just looking at if constructs and if then else's, we're going to look in this lecture at loops. And it's basically works the same. It's just there's a little bit more stuff that you need to keep track of. So we're going to be dealing with the pseudocode on the left part of the slide here. So what does this pseudocode do? It takes a value x, and while x is less than or equal to 10, keeps doubling x. Once x is greater than 10, x is going to be displayed. So how do we translate this into assembly language? Well, we pretty much proceed like we did in the last lecture segment. The only real trick is going to be how do we implement the while loop. So to input x, again, we don't have an I/O device, so we're just going to load x from RAM. So we're going to load the value at label x. Here it's going to start at 2 into R0. And then we're going to have to load our other operand to our comparison into R1. So we have a label called num, and at that label is stored the value 10. So now R1 is going to contain the value 10. Okay, so that's sort of the setup for the while loop. And now we're not going to look at the while loop quite yet. We'll get to that in a second, but let's look at the end of the program. At the end, we're going to display x, so we're going to have a label called done. We're going to jump to this label when we're finished with the while loop. And when we get here, we're going to store whatever's in R0, that is to say x, into an output variable. The output initially contains 0, but it doesn't matter what it contains. And we're going to do that instead of displaying it because, again, the supercomputer doesn't have any sort of a display. It doesn't have a monitor or whatever. Okay, so now let's look at the interior. So here are the rest of the instructions. So we have a label called W, which is the top of the while loop. And at the bottom of the while loop, we're going to have a jump back up to W. The stuff inside is the while loop logic. And we've already looked at the stuff at the bottom and top. So what we're going to do is go through and simulate the execution of this program kind of in our heads on the slide and see the dynamics of how it plays out. And that's great. We're going to learn how while loops in assembly work. So let's get started. Okay, so at the very beginning of the program, the first instruction is load x into R0. So x is a label pointing to a memory location containing the number 2. So now R0 contains 2. So we're going to track our program state over here, and we're going to track where we are in the program over here. So then we load num into R1. So now R1 contains 10, as we discussed earlier. And now here we have a label W. This is where we're going to branch later. So remember, W doesn't do anything. It's just going to let us use this address later to talk about it. So we're going to execute the comparison instruction. The comparison instruction asks the question, is R0 greater than R1? So if R0 is greater than R1, we're going to, the BGT done, the branch greater than done, is going to make execution of the program jump to here. But that's not the case because 2 is not greater than 10. So remember, it's a conditional branch instruction. If the branch condition is not met, if we don't do the branch, we just fall through to the next instruction following. So that's what we're going to do. So now we're in the body of the while loop. The body of the while loop, if you remember, doubles x, multiplies x times 2. So x is stored in R0. We add whatever's stored in R0 to itself and put the result of that in R0. So now x contains 4. So now 4 is in R0. Okay, so we're done with that instruction. And what do we do next? We jump to W. So we go to the next iteration of the while loop. And now we execute again. So now we do the comparison again. So the question now is 4 greater than 10? It's not. So the BGT condition is not met. We don't jump to done. We go to the add another time, and we double x again. So now x is going to contain 8, or R0 is going to contain 8. So after that, we unconditionally jump back to W. So we execute the while loop again. And this time, it's going to compare, it's going to ask the question, is 8 greater than 10? Well, it's still not. So we double x a third time. X is now 16. And we jump back to the beginning of the while loop. So now we ask the question, is 16 greater than 10? So remember, that's what's accomplished by the pair of the comparison and the conditional branch. Is 16 greater than 10? It is greater than 10. So the branch condition is met, the conditional branch fires, we jump to the done label. So now we jump to the done label and store whatever's in R0, whatever's in X, to the output. And so the output contains 16. So if you run this, if you type this assembly language program into the simple computer and you run it, then you should get 16 in the output. And of course, we're going to then fall through to the halt. And so what have we learned here? What we've learned here is kind of how to structure a while loop in assembly language. And the way to think about it is a while loop has the condition, the test, at the front of the while loop. It always executes, it always checks the condition and then executes the body. And you can see that that flavor of the while loop, that structure of the while loop is reflected in the structure of the assembly language we had. At the top of the while loop, we check if the condition is true. If it's not, we exit, or we're done with the loop. If the condition for the while loop is true, then we execute the body of the loop. So that's basically sort of the essence of a while loop. And here's how to translate to assembly language. And it's kind of, it's a moderately complicated thing we're doing here. There's kind of some moving pieces. You sort of have to have your ducks in a row to get this all working. And so we're going to have you, of course, do some practice with this.